We are going. Is there any term? Colors. Gray. Colors. Colors. Come to the side. Come. Green. Yellow. Nine. Oh! Fertility. Fertility talaga anti. Salila. Sige, so fertility. Someone to sleep. Someone to sleep. Oh,
Time.
Look at it. No. Baby. Look. Let's wait. Next Sunday. It's the friend. Also, must be going. Cecilia, Matt,
Thank you so much, Cecilia.
yeah, welcome.
You can go. Do you want to eat here or do you want to go eat?
I'm going to eat at that.
You can also get
Okay, it's fine, no problem. Nah. The way.
Okay, good evening, team members. Um, I hope you are all doing well this evening. If you are doing very well, give me thumbs up. Hope you're all doing well. Give me thumbs up. Okay, thumbs up. You are all welcome to today's breakout session. We are going to have an amazing time today. So, here is the case. You would so this is what I'm thinking. Last week we couldn't complete our project on logistic and classification project. So and then I was hoping that in the course of the week I was going to get the feedback on for those who tried their hands and I couldn't get in. So one way or the other, I believe maybe we should go back and finish what we started, and then quickly proceed to today's um, topic. So are you all with me? Should we go and then finish what we started last week? If you are with me, give me thumbs up. All right. So for today, we are going to use Python, Anaconda um, environment because data lab was running a bit slow last week and we held out for a week. So I'm going to set up my Anaconda and then share the screen down. We'll continue our section today. All right, so sharing my screen now. Okay, so this is my screen. So let's quickly run up what we did last week. So last week we started with a classification task, and then our assignment was to build a logistic regression model. So let's quickly brush through. I know we did it last week, so let's get it back to surface. What we did was we imported our dependencies, and here what we have is pandas and numpy. So I'll run. Let me quickly do this. So we start with our pandas, and then numpy. Then we load our data. So we have the f.f. it gives us the first 5 rows. So here is our data. We have our ID column, we have diagnosis, then the radius, we have the touchdown, we have parameter, we have area, we have the smoothness compass. So this is a dataset on breast cancer, and then this is the data on the how the breast and how the cancer file looks like. So this data was recorded using a tool. This is a clinical tool used to record data. So if there is a cell that is growing in the breast one or the other, and we can measure to see if it has a real growing to cancers or not. Now let's move on to our data for a second. So we check the shape of our data. We have 559 rows and 32 columns. And then we have an information on our data list. So this is the information we have on the data. We have our ID, we have diagnostics, the region, the cluster, we have the symmetry, and then down to the factor dimensions. All right. And then there are some columns we are not going to need in our data set. So we have to get rid of it. We do not need our ID column, and looks like the unnamed entity here is an empty. It's empty. So we have to get rid of it. We are seeing 0 now, 0 not now. We have to get rid of it. So let's see if we can help and get rid of it. So what we have is we have DFS now. This function, what the data that it is showing us whether we have any missing value in our data set. So when you are seeing false, it is telling us that you have no missing value. If you see true, wherever you see the true, it tells you that our portion has a missing value. And we can also sum it. So when we sum it, here we are. We are getting 0, 0, 0, means that there are 0 missing value in each of the rows we have. Then when you come down, we are seeing on name 32. It tells us that these are all missing values. For that matter, we are supposed to get it. Here, I'm going to do the function we use to block, but then think I can also add the ID here so that we will just drop both of them. So I just have to add the ID, yes, ID, and then I'll hit enter. And then what I'll do is that now let's check if we have our data, if we have them in our data frame. Okay, so yes, the info. So we can see we no longer have our ID with us. And then when I come down here, we are no longer have our name column. So they've been rid of capital for we don't need them here. So I will just go and then delete this cell. And then our fix this. Here we are now. So let's perform a very simple feature engineering. In this course, we are going to do feature engineering as a course, and then you have time And once during one of the breakout sessions, I'll take you through all the feature engineering we do in machine learning. So for here, this is just administrative feature engineering so that you can just proceed. But do not worry if you don't understand what feature engineering is. You calculate one way or the other. So I'll go ahead and what I'm doing here is that machine learning algorithm do not recognize objects. They only recognize either float or integer. So when you look at this, our diagnosis column, we are seeing n here. So let me just, give you a function. We have the f, and then the f, and our column is diagnosis. Okay. So I'm going to use this unique function. So what this is telling us that in this column we have n, okay, and then we have what p, right? This is a cancer 10. This is malignant, and this is what winning. So because they are objects, we do not need objects in modeling our data. What we are going to do is we're going to convert this object into something we call label encoder, where we are going to assume them as 0 and 1 because we are dealing with classification. So when you are dealing with classification, you encode your dependent variable. Okay, you encode the dependent variable. So here, this is showing us that we have 2, and then since we have 2 here, we're going to encode them as 0 and 1. So malignant means that the patient is cancer, and then benign means that the patient does not have cancer. So this is just a function, a simple feature engineering function to encode our diagnosis column. So our fit box, and then our fit here. So you can also see we have what the n here. So let me come up here. So all these were and here I stated that n should equal to 1 and b should equal to 0. So we have 1, 1, 1, 1 here. Yes, let me. All right. So in our next, what I'm going to do is that I'm going to display the value count of the diagnosis. Value count. All right, so this value count is now telling us the number of people that have been recorded as cancers and the number of people that were recorded as non-cancers. Okay, so just as I expect, the 0 here, we have 357 patients. In all, our data set is 569. So out of the 569, 0 was indicating of benefit by the patient who has cancer, and then who did not have cancer, and then 212 is a patient who has cancer. So let's move on to our exploratory. This is just a simple exploratory data analysis. Um, in, uh, in, in the, we are going to um, in one of the interactive session, I'll take you through how to perform fixes, normal distribution, how to understand the data using normal distribution. In case you have outliers in your data set, how to handle outliers, what is even outliers, how can we get outliers in our data? I'm going to take you through that. But right now, our cut is a fixed logistic regression. So I'll go ahead and do that. So here is just a simple statistic. You can see here. We have the count, then the mean, and then we have standard deviation, have the minimum value in each of the columns, and then the maximum value in each of the columns. So let's just finish what our heat map. I think we did that last week, but let me just what our heat map here, and then see. So we are going to use these two libraries, Seaborn and Mark Raleigh, to plot our graph. So this is it. This is our heat map. It will take some time to load, but it will eventually show up. My idea is our heat map. So you can see here there is a bit confusing because we have a lot of variables, we have a lot of features in our data set. So I'm going to make it a little bit simple for us to see. So I'll come down to this code and this what this gives us. So yeah, so I'll explain this shortly. What you see here is the diagnosis column, and you are seeing 0 to 1 because it is our dependent variable, and everything here you see here is our independent variable. It is 1 because we want to know how each of these independent variables correlate with the dependent variable for diagnosis. So you cannot see you have the radius mean it is somewhere between almost maybe 0.7. We have the tester. Tester is around 0.73. I'll come down to the symmetry mean, which is very little, and it will also show you a negative correlation. That means that it has not really have any correlation with whether a patient has a cancer or not. It does not. So as you can see, we have displayed all the columns in our data set here, and the data that we have, can see that the concavity is the highly correlated column in the data set, and it is showing about 0.79. Let's get to 0.79. That is not yet at 0.8. Right, so this is a highly correlated column in the data set, and the lowest is what is showing. I think it is not display. Okay, the area symmetry is the lowest, is the negatively correlated in this data set. Okay, so this gives us a brief info about how data sets correlate with each other. It's important to do this because sometimes it tells you how your model is going to behave. So if you have a data set that has each of all the columns, correlating with the dependent variable at a very low probability, okay, you can tell that one or the other, your model will perform very bad. All right, so let's move on. Today, all the, this is just a function to show the integer. So the column that displays integer is diagnosis, and then I'll just show a simple graph here. So this is a simple graph. This is a simple graph those who do not have cancer, and then those who have cancer. So let's move on. Our next task is to pick our model. Good. So I think last week we did feature spelling, and what this means is that I think I explained, but let me go over. What this means is that let me let me um, let me display our data sets and then briefly. So what this means is that some of our values are showing very significant figures. Some are showing 4 significant figures. Some are showing 4 decimal places. Some are showing 1 decimal place. When you go ahead to fit our model, the model may perform value because it may assume that all these things we are seeing, all the figures we are seeing here, one has a higher value than the other. So what feature scaling does is that it converts everything here to have a standard deviation of 1, okay, and then a variance of 0. Now it converts everything so in modeling the data, our model will assume that yes, we are all on the same weight. For that matter, there wouldn't be any issue with our model. Okay, that is why we perform feature spelling. Feature spelling is very important when you are performing classification tasks. Although there are some of the algorithms that do not really rely on feature spelling to do their work. In logistic regression, feature scaling is very important. So what I'll do here is that from SLM, like create regression, we import a comma scalar. Comma scalar is one of the feature scaling techniques used to scale your data. So I'll go ahead to run it, and then we have scalars equal to comma scalar. That's what you import over here, and feature is equal to behave.drop. So last we did something like drop. What this means is that our diagnosis here is the dependent variable. So we do not want this scaling to affect it. If when it affects it, I mean, you may not even be able to find the probability of a patient who has cancer and who doesn't have cancer. So what this function is telling us that we want to scale every column here except the diagnosis. So we are dropping the column out of what the scaling we are performing here. So I'll go ahead to run it. And then now, since I've run it, I have given my data frame a new name for still here because now we have scaled it to have to assume a different personality. Okay, so here is my scale here that head. So also we have scaled it. We have scaled our data. Like now once we come to diagnosis, we still maintain our diagnosis to have 0 and 1. Right. So in our next session, we are going to put our model. Yeah. But what I'm going to do is, first of all, I'm going to split the data into two. So I'll save this as train test. Let's let's train and test that. Okay. So we are going to split our data into two. Yes, we are going to split our data into two. That's the train data and then the test data. Before I proceed, I want to ask a question. In machine learning, we split our data into two. Who can um, answer me why we split our data into two? Anyone? Okay, Enoch. Enoch, let us hear you.
Okay, good evening, sir.
Good evening, Enoch.
Yes, sir. Please, can we get the data set of this project we are working on, please?
Okay. I think are you on the Discord channel? Because I think I sent the Discord
Okay, you sent
channel.
it to the Discord channel.
Yes.
Okay, let me check. I'll go and check now. Thank you very
Alright.
much.
Alright. So we have Jonathan. Jonathan, go ahead.
Okay, good evening, sir.
Good evening.
So, sir, to answer the question, we split our data sets so that we can test how functional and how good our model is. Because if we don't split, we would only have one set of data to work with. So, if we train with that data and test it on that data, it may perform very well, and that may not show how that model would perform in real life because it may have memorized the data instead of learning from it. So by the time we use it on new data, it may not perform properly because it just crammed the relationship between the data we trained it with. So when we split it between train and test, we can train it with one fraction of the data and test it on data that it has not seen before. So if it performs well on that part of the data that it has not seen before, we assume that it's going to do well with new data as well.
Okay. Okay. You are right. You are right. So we split our data because after training our um, data, we want to know how best it is performing. And another data set that has not seen the training. Because if we put everything here to train, how we would assess or evaluate the performance of our model. Where we split the data into two, so that you know how best our model is performing on and on scene. Where we call it what an on scene data. All right. So thank you, thank you. I think another person has also raised his hand. Okay, Enoch again. Enoch, let me hear you out. Enoch, your hand is up.
Sorry, that was a mistake. Let me bring it down. Sorry.
All right, okay. Okay, so let's proceed. So um before we split our data into two, we're going to use an S a scikit-learn function. Okay. What this function does is that it's automatically do the splitting for us. You don't need to, put in some mathematical function and what some, code that at the end of the day, get you confused. So I'll just go ahead. So from S sklearn dot model selection, you now import train, call it train test splits. What it does is that it splits our data sets into two for us. Okay, when I will run it, it is in. So now, before we split our data into two, we have to label our data set. So we are going to label them into two. That's the dependent variable and then the independent variable. So I will start with the dependent variable, and then I'll give it what x. Okay, and then x equal to. So and the kind we have our new data sets is name of still the head. So if you go back to the F, what you do is that you are going to skip what the fill data, and then you will go here and then use this data, and our model may form not as you wish it to be. So we are going to use the scaled the F. All right. So we are going to need all our features here, except diagnosis. Diagnosis is our dependent variable. So we are going to use all the features here except diagnosis, which means that if I'm calling this X and I'm not going to need the diagnosis, I should then what drop it. Okay, so the F was drop because I don't need it in our independent variables. Okay, drop, and then I'll call the columns equal to diagnosis. All right. So and then our y, okay, let me fix, and then y will be equal to fill the F. Now our dependent variable is what diagnosis. So we are just going to use diagnosis. So fill the F and this. Okay, diagnosis. Okay, so now it's enter. All right. So now let's split our data into two. So what we do is that we first call extreme, extreme, extreme. And we are also going to need our x so x, x. Then we are going to need our y, so y n, and our y f. Now, so we are splitting our data. We have x string and then x test, and then we have our y string and then our y test. Okay, so I call it string f f into brackets. So we are splitting our data out, and I'll need the x here. So x is there, and I'm going to need the y here. So y is there. Then we are going to need our test type. That is our since we are splitting the data into two, we have our training size and then our test size. Mostly, it is advisable that your test size should contain 20% of the data. So that your training size will have 80% and your test size will have what 20%. So I'll say 20%. So if I when you convert 20% into decimal fraction is 0.2. So I'll have my test size, the test size equals to 0.2. Oh, sorry, 0.2. And then you know, we call a random states. Random states. Since it is random, I'll give it a random number too. So random states equals to, then what do I do? I fix the button. I hit my enter. All right. So now let's go ahead to, before we hit our logistic regression, let's call in our uh, algorithm. So from the same SQL, because um, supervised learning, right? And in the first code that we did was titled supervised learning with S scikit-learn. Okay, so scikit-learn or sklearn, and whichever way you call it. So again, because it is a linear model, we're going to use linear model with linear model. Then import logistics, logistics regression. So this is our logistic regression, and I'll go ahead and I'll hit. Okay. I have made a mistake here. The logistics regression. So I am getting I'm not import logistics regression from sklearn. Okay, linear model. All right. So that means that one way or the other, my logistic regression has not been restored. So no. Okay. Hold on for me, everyone. Let me check something from my. Okay. Okay. All right. Go ahead and ask the question.
Good evening, sir.
Good evening.
I think the logistics has no S. Maybe that's why it's giving an error.
Yes. Thank you very much. Okay. All right. I brought X here. Sorry. Okay. There we go. All right. So now what we do is we create a model. Okay. We create our own model, and I'm going to name my model. I'm going to name my model. So I mean, when you are performing this task, you can also create. So when you use a hashtag here, and then create 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 a model. Right, then I'll come here. So I'm going to use, since we are working with logistics, so let me use something like an LR, okay, or maybe something like log red, or maybe I can just use log, or I can just use L, or let me just use log red. All right, equals to um, our logistics here, right? So logistics. Yeah. I'm very mindful of the X this time around. So logistic regression. Okay. Then I think all right. Okay, so the next thing is to now fix our model into the data we split here. Once I name my model log rec, when I log rec, that fix we fit it into our X train, and then now we train our data. X train, and then Y train. Okay, let me get this here. So for X train and then Y train, and then now we have our logistic model. Okay, so let's go ahead to now call our predict function. So Y predict, okay, because we want to predict our model. Then when we use log rec here, I'll now bring our log rec here. Then predict out X test. So now you want to predict the unseen data. Okay. So what you are seeing here is that now we want to predict our unseen data, and I'll go ahead and I'll just click in. Okay. So before we check the model evaluation, let me call on a function that will give us a probability of a prediction. So I'll use the same Y predict, but this time around because I want the probability, I will add a probability to it. So predict will be something like 12, so we want the probability. Okay. Then I'll call the same log predict, but predict, and then I want the probability. Okay. Probability of the X test and X test, then colon the first positive probability, okay, row, comma, 1, and then okay, okay, well, I think I am supposed to do something. That's so what do you do? Okay, you cannot. Alright, okay. Let me clear this. Since I already call on this function, what I have to do, I should just go ahead and evaluate the model, and then from there we find the probabilities. Okay, so let me say model evaluation. Okay, let me just call in this. Alright, so before we evaluate our model, we are going to use a metric. So we are going to import our metric. So first of all we are going to assess our accuracy and the F1 score, our precision score, and then our rate score. So what we do is from SPLN, the metrics, yes, we want to find the metric. We import first our accuracy score, and then F1 score, and then precision, precision score, and recall, recall, score. Okay, so now what I do is that when you call this accuracy, accuracy, then accuracy score. Okay, then equal to accuracy score, and then we bring in our y-text because we want to access the performance of our test data. Okay. Yeah, and then our prediction. Okay. And then I'll go ahead, same for F1, F1, F2, F1, for Y, F, and Y, 0. Okay, and position, position, we have a position core, which we have a Y, F, and Y, F, then the last one is recall, and then recall, middle, recall score, recall score. And then we have our Y, and then we have to enter, and what I do is that I go ahead and then so monitor accuracy. So we have our accuracy score to be 0.973, blah 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 blah, and then 0.9 is telling us that your model is performing very well, and that our test set is generalizing well with our training set. Let's go ahead and check our F1. F1, it will give us 0.96. If it's what I did, our model is doing well. Let's go to precision, and then our precision is occurring up. Precision is also given us 0.976. So, that is good. Your model is performing well, and then finally our record. And we have our record to be 0.95. Okay, good. So, this is our model evaluation, and as it stands now, we can say that we be able to fix a logistic regression to a data. And from what we have seen, our model is performing very, very well. So I will enter, I will use this for question, and then I'm hoping that I was hoping that we will try our hands on a regression model since supervised learning is both regression and logistics. So we will try our hands on putting a regression model as well. So I just enter any question, or any question you can ask. So maybe the next question. Can we now proceed to our regression model regression? Hands up if you want us to teach our regression model. We need hands up. I want to know if you are on the call and then we can follow you on it. Okay. I've seen the area. Okay, but I guess okay. Oh, keep it up, keep it up, keep it on. Keep going. I think I know the new one here. So this is um, a clear walkthrough of how we can perform a logistic regression model. Yes. So let's quickly start with our regression. Okay. So what I'm going to do is I have a very simple data set here. That's I'm going to use our regression model. Okay. So hold on for me, everyone. I'll go to plan. All right, so contrast. Okay, so this is our regression problem, and things we also already got through logistics, so I will not really take much time here. So let's quickly start for our import dependency here, and then our data set is here, house price regression. Then yes, so this is we are going to predict the size of a house, and this is what our data contains. We have bedroom, have the bathroom size, we have the square feet, we have the house age, how old is the house, the distance from the house to the city center. Does the house has garage, the quality of the neighborhood, and then the price of the house. So let's go ahead and see. We have 500 rows, and then we have 8 columns here. And then the information we have our data set, we have 500 now that we do not have any missing value, but let's go ahead and check if we have any missing value. All we are getting here is 0, so there is no missing value. Okay. We are getting false, yes, so yeah, we do not have any missing value here. So let's go to summary statistic. So what we have is that we have bedroom here, have the minimum value here. We have that for the showing of negative. Means that we have an outlier in our data set. For some reason, we're not going to handle outliers today. During our data pre-processing and feature engineering, we are going to look at outliers, how to deal with outliers and interline data sets. So for today, we are going to leave this out. And then this is a scanning statistics. So we have 500 counts, have the mean, so this is the mean of the square feet, and then the mean size. So we can say that the minimum price of the houses that we have here is 926, and then we can say that the minimum price cost 275, and then the maximum cost 1,649. So this is the only statistics of our data set. And now let's move on. I want to do this simple graph. So let's see what is this. We can take a simple graph. So we can see number of bedrooms and the price request. So we can see that if a bedroom costs, if the bedroom, you have a 2-bedroom house, it's much lesser than a 3-bedroom house. My 3-bedroom house is much lesser than a 5-bedroom house. Okay. This is what our graph is showing us. So let's count our bedroom. So yes, we have the 4-bedroom house. So out of the houses that we are selling, we have 4 bedrooms, we have 112, and 1-bedroom house 109, 2-bedroom cost 2-bedroom house 95, 5-bedroom house 93, and then 3-bedroom house 91. Okay. So this is just a goodbye of the bedroom houses and the houses. Yes, so this is a box plot. And what box plot is? A box plot helps us to deal with outline. So when you are seeing anything beyond these boxes that you are seeing, the fact that we have an outlier in our data set, there is a price range that is out of the range that our price is supposed to look. So for instance, you can see this small dot and this kind that we are beyond this range. If you find that we have outliers, and then when you come to 1-bedroom house, you are having an outlier here. This is what box plot does. In statistics, it helps you to detect your outliers in your data sets, but you're not going to handle them when you're out there. I think I brought in a simple function here that helps us to detect our outliers. So what we are going to do is that I don't know if okay, let's just go to for this to get along. So this function is to remove the outliers. Alright, and before we remove outliers, we are going to use the 25 quarter, the here on the level answer. We are going to use this and then node B. Right, we are going to subtract this from B, and then what we are going to get we just pass it through our data, and that is called the first and the third pattern where we are. We want to subtract it and then we add the lower limits, and then we get rid of our outliers. So this is how. So now we have gotten rid of our outliers, but I'm not going to, for time's sake, dealing with outliers is not part of this course, so I'm not going to go deep into that. Let's check our regression. Let's check our correlation. So here is the correlation. Here is the price of our data. Here is the price of the column size we have. And so what it is telling us that bedroom, the bathroom, and then the size of the house contribute massively to the price. While the house age, so it shows that when people are buying house, first of all, they don't consider the house age. They don't really consider the distance to the city center and whether the house has garage or not. I mean, if I don't have a car, I'm buying a house. I'm not going to consider a garage, which is And then, so this has a negative correlation in the neighborhood currently. It is showing a positive correlation. But yes, so it is not, does not really influence what the price of the house. But if I'm buying a bedroom house, I mean, if I want 2 bedroom and you are pricing it the type of a 4 bedroom, what will I do? I'll walk away. If I mean I want a 2 bedroom, give me a price of a 6 bedroom, that means that's one or the other. And people consider the number of bedrooms when they are pricing their houses. And what I also seeing is bathroom, uh, assuming the house has for 3 bedrooms, but it has only one bathroom. And then the other house that has for 3 bed, that has 3 bedrooms, and each of these bedrooms has a bathroom. That's 3 bathrooms. I think I'm going to consider a 3 bedroom house with a 3 bathroom over a 3 bedroom house with a 1 bathroom house. And the square feet of the house that I mean that is a compound big enough for me to kind of like assuming I want a small garden in my house. Is a compound big enough for that, and I want a space where my children can roam about with. So it's a compound big enough for all these. I mean, so the data is giving us information on how people consider when they are buying houses. Right? So we, from here, we are going to perform a linear model. Okay, and then from there, we perform a multiple regression. So there's a bit of linear regression, and then so I'm going to come to linear regression and a multiple regression. So I'm going to put out that in here, and I'm taking square feet because square feet have the highest correlation among these three. So let me put in square feet here. So oops, okay, and then in the putting square feet here. Yeah, and I'll go ahead and then I'll okay. I think I have not imported my test scripts. The reason Hello everyone. I've had a little issue with my laptop, so I'm reloading, and then we continue for where we ended. So as we are waiting, if you have any question, you can ask me, and then we proceed. So, if anyone has any question for what we have done so far, if you have any question, you can ask me. So this time is for questions, and yeah. Okay. All right, Hikma. All right, ask your question.
Good evening, sir.
Name.
So sir, I noticed while you were creating the independent and dependent variable for this regression, you did the dot value and the dot reshape. I want to understand why, but when we we're doing that of the classification, there was nothing like that.
Okay, so here is it. What I'm doing is that I am fitting a linear regression. Okay, and then when you are fitting a linear regression, we do not necessarily split your data, okay? Because we want to see how we are just making a prediction, right? So I can just say, okay, let my X be this and let my Y be this, and I'll just go ahead. And then because all the data points are one way or the other, not, skilled, okay? That is why we use reshape and then dot value. All right, so when your data points are not scaled, unlike we did in regression, you have to use a reshape so that one way that your model will assume that if you have about 4 decimal places, and then you also have 2 decimal places, all right. The decimal place do not have a higher weight more than the 2 decimal place. That is why I call that function the reshape, and then the dot value.
Thank you very much, sir.
You are welcome. Is anyone else? Okay. Yes, go ahead.
Sir, please, is there a reason you chose only one feature for your value of X?
Is there a reason I chose only one?
One feature, you just chose square feet, I think.
Yes,
And
because we are performing a linear model. Okay. When we are performing multiple regression, we are going to consider all the features. Okay, so what we are doing now is that first we are performing a linear regression. That is why I chose only one model. When you perform linear regression, since it is linear, we are only going to make use of only 2 data points. That's your independent variable and your dependent variable. But when you are performing multiple regression, you are going to use more than one independent variable.
okay, thank you, sir.
You're welcome. All right, I'm setting up my laptop as we wait any more questions. Okay, go ahead.
Hi, sir. I wanted to ask if you would make your notebook, your Jupyter notebook, available for us to assess it and study upon for just to get better. Thank you very much.
I think, please come again. I did not really hear you clearly.
Okay, no, sir. I said I want to ask if your notebook, the Jupyter notebook that you use for this class, will be made available to us, maybe on a Drive link, so that I can iterate upon and everyone else.
Okay, all right. So, um, I'm using Jupyter Notebook on the Anaconda environment. So, if you want to get access to it, all you have to do is just Google anaconda.exe, and you get access to it, and then you download Anaconda. Once you download Anaconda, in the Anaconda environment, you'll be asked to download the notebook that you are going to need. So we have Jupyter Lab. If you want R, you can install, and then I think you can also install Jupyter Notebook as well. And then if you want R Studio, and then I think maybe Visual Studio. Yes. So I'm going to show you a picture of how Anaconda Navigator looks like. Okay. I hope I can do it. Hold on for me. Let me try get it. Okay, go ahead and ask the question as I am setting up the environment.
Okay, for me, I use VS Code. I was wondering if maybe it would be better if maybe there's like a file, like the notebook file. I think it's yeah, maybe that would be better so that instead of having to have two IDs for
Okay, so apparently you can only use the Jupyter Notebook in the Anaconda environment. It's kind of like it is built in. Okay, so I don't know if currently, but as far as I'm concerned, you can only get access to Jupyter Notebook when you have the Anaconda Navigator. Okay, so okay, go ahead.
Okay, I think if he's using the VS Code, you could just from your Jupyter Lab or Jupyter Notebook, click download, then download the .py file. So if
Okay,
he uses the .py file instead of .pynb, he will be able to open it with the
all right.
VS.
All right, and I think you can also install extensions on VS Code. Okay, I think on VS Code you can search for Jupyter, Jupyter Notebook or Python, and then you can install that extension. So you can use them on your VS Code as well. So depending on which one you want, either you want to use VS Code or you want to use Anaconda, you can do likewise. So for those who want to use Anaconda, just go to your okay, I think I'm restoring my laptop now. Okay,
Hi, Dixon. Sorry, I can't hear you. Or are you saying anything or you are purposely muted?
Everyone, I didn't know that I have muted my. I
Oh,
didn't
okay.
know.
Because I mean, I don't think anybody was hearing for a while.
All right, so I was saying that once you download the Anaconda Navigator and then install on the machine, this is how the environment is going to look like. So here is data spell. I don't need data spell to have cannot install it. Here's Anaconda notebook, the CMD Jupyter Lab, and then when you scroll down here, this is the notebook that we are using for today's task. And then we have the PowerShell prompt, and then it's either then there's also VS Code here. Yes, I have VS Code, so I can launch VS Code right from what my Anaconda Navigator. And then here's other we have. And then for this one, since I don't need them, they are not installed on my desktop. Here's our studio and then Python. Okay. So all right, Ibrahim. Ibrahim, let's hear from you.
Okay, I wanted to ask the presentation you did today on classification and regression taxes. Can the template be shared for the code that you wrote?
Okay, yes, I can share it. I'll share it in our Discord channel after this
Yeah,
session.
and also the data set for the regression task also.
All right,
We don't have that.
I'll share all of them after today's session. After
Okay,
the
thank
session.
you.
All right. Okay, other hand of the way. So, all right, so this is that. Let me go ahead and let's continue from where we ended. Okay, so here's my regression. So I think since it's up, let me run everything all over again before then make some adjustments here. Yeah, we're not going to need this when we take it out. Yeah. So let's run everything okay. So we're running everything. All right. It will take some time, but eventually you will get it. Well, is it taking that long? Yeah. When it- okay. So and yes, and then let's off on place of the first. I think okay. operator. And here was supposed to be square feet. Square feet. And just put in one. Right. So now data even test fits, and then just as I said, dot value here. So I've explained this, and then I'll go ahead and then split our data into two. So now we're going to create a linear model. Okay, so how do we create a linear model? Then we use something like regress rate. So let's say rate equals to regression, linear regression. Yeah, linear regression. Hit enter. Oh, sorry, I have not imported linear regression. So from sklearn dot linear model imports linear regression. Right? There was a mistake somewhere. Oh, I'm not supposed there should be space in between this. Right? The linear regression is up and running. Then now the next thing is to fix the model. So we're going to use things I've named it with. Let me use with dot fix. Then I'll call my x and x since we have already was when with the data into two. I'll use x in x in, and then our y in. And then we have our linear regression up and running. So then we be able to use the prediction function here. If not, we'll just go ahead and evaluate the model. So let me see this one will work. Prediction, and then okay. Okay, the prediction is not working here, so since I just have to clear it, and then now all you have to do is go ahead and assess the performance of our model. Okay, so I'm going to use import metrics just as we did in logistics regression. So let me call my y credit y head equals to rate dot credit, and then we have our x test, and then I'll put, and then now let's import regression and the metrics. So from SQL dot metric import scale, okay, for roots, and then scale root squared roots squared square okay. I mean, thinking about it here. It's a new thing that I've never, actually I've never been installed. Oh. Okay, so what do you do is let me call this off and give me some few minutes. Okay, all right, so yeah, go ahead.
Sir, I think you meant mean squared error, not root mean squared error. The root mean is just how to score, right?
Yes. Thing is, I'm trying to use the RMS mean and then R score. Okay. Give me some few minutes. All right, so I'm back. Let's do this. So let me share the screen now. So here we are going to use the mean square error and then our check. So I want the outputs and then I can use both of them. No. So here we are. I think so. It means that what means that error. And then I think I'll give it to R2 output code. Then on R. All right. So yeah, that's what I wanted to do in the first place. So let's go ahead. We'll have our square. let me use NSE. Let me use NSE. Copy and the mean code error into brackets. Y and then now Y. And then NSE will be very straight to comment. And then after out let's say R and give R3, let's say R2 4 into bracket Y Y plus N Y 3. Okay, I cannot use this term. I will now be. Alright, so this is the performance of our linear regression model. So yes, this is our linear regression model. We've been able to fix our linear regression model, and our R score is giving us a 97.97 performance here. If otherwise, our model is generalizing as well, but our data actually. So let me quickly run through the multiple regression. Move this multiple regression, multiple regression. So we've already imported our XWY test, split our data into two. So what I'm going to do here is that yeah, X, my independent variable. Okay. And then since this time around, I want all the features here. So I want all the features here except the dependent variable. What I'm going to do, I'll just drop the dependent variable out of what the column. So what I have will be F. Then I'll drop it into bracket, column equals to 5. I should put this in parentheses, and then I'll close it. Then I'll add the values here. Okay. I think again, this happening here. So putting 5 here, but value. Okay, and this box here, and then suppose to maintain it. No. Alright, I think I should perform as this. So when we do this, we have 5 and then aggregates equal to 1, then the value, okay, then my y is now bf, and then 5, now let's see the data. We have x, then x, x, y, then y, x, equal to 10, x, x, okay, we have our x here, and our y, and our test size, it is 0.2, that is 20% of our data, and then our random state, which is actually, so from here, all you have to do is just take your, I mean, the regression model. You have already imported linear regression here. So you create your regression model, you fit in your regression model into your X and then Y plane. But I think here, if you are creating a regression, creating a model, I'm going to use okay, since you are working on multiple this multi thing, because once you use regression, it's going to affect the other regression model we are using. So we name our regression maybe multi, which is also multiple regression or linear regression. And multi, which equal to linear regression. Now it's 6 multi, right? That's it into your X plane, and then your Y plane. That's our regression here. And now let's comment our Y credit equal to multi regression dot credit. Dot credit. Then you have a X first. Okay. All you have to do is let's now call our model. So we have let's select the component. So let's copy it from here, and then our window here. And then I'll go to the MLT, and then there's our MLT here. So you can compare the multiple regression MSC, and the linear regression MSC is here. And then I'll just go here and I'll say copy this, and then go here. Out, close, we have a 0.999, so control the multiple regression R square, and then the linear regression R square, right? So finally, we've been able to put our data into both a linear regression and then multiple regression. Thank you very much, everyone. So our next task is to work on fine-tuning hyperparameter, and then we're also going to work on cross-validation. We have other types of regression called laughter regression and weight regression. And then we are going to work on all that. But our task for today has been complete. And I'm going to the end here. Thank you very much, everyone. So, who can turn? Is there any questions? Okay. All right. If Mary can ask the question. If not, ask your question.
Sorry, sir. I was just clapping. I don't have a question, sir.
Okay. Thank you very much. Thank you very much. Thank you. All right.
Hi, Mr. Dixon. Thank you so much for your time. Please, is this being recorded?
Yes, and it will be on our Facebook page by Wednesday, God willing.
All right, thank you very much.
I also send the link. I think last week's recording was sent to the Discord channel. I hope you saw it. Yeah. So everything you do here is being recorded and is on YouTube channel. So in case you are finding it, just go to AI Community Africa on YouTube, and you're going to find under machine learning, you'll find this video. Okay. All right. So any more questions? Okay. Let me hear you out.
Good evening, sir.
Good evening.
Please, what of the attendance link?
Yes, I am getting it for you right away. Great.
All right, sir. Thank you.
Okay. Is there any more questions? Keep your questions coming, okay? Please keep your questions coming. Okay. We'll go ahead. All right. Enoch, go ahead. Go ahead. Enoch, go ahead and ask your question. Okay. Ibrahim, ask your question.
Okay, please. What is the difference between the normal regression and the multiple regression that you just used.
All right, so the difference is that, let me show that here. When we are taking a linear regression, okay, what we do is that the linear regression, when you say we are taking a linear line, we are only considering only two factors. That's one is your independent variable, and the other one is your dependent variable. So with the linear, all you have to choose is to choose your dependent variable, right? So here our dependent variable was a 5, and then we chose square root to be our independent variable. I can also choose price or independent variable, maybe model, maybe vacuum or bedroom. So I can choose any one of these as my independent variable. But with a multiple regression, we want to see how all these, okay, all this is affecting what the price. All right, so realize that when you choose only one the one independent variable, that is the square root, we saw that our model was performing at a percentage of 97. Okay, but then when we considered all the independent variables, okay, when we considered everything here, realize that our model was performing at rate of 0.99, which means that um, you cannot only make, I mean, adjustment, or you cannot price, or you cannot, I mean, predict the price of a house by using just the square feet, right? If you want to know the actual price of a house, you have to consider the bathroom as well. You have to consider the number of bedrooms. You have to consider how old the house is, when the year it was built. You have to consider all of them. So that is what, I mean, the linear and the multiple regression. It's okay. That's the difference. Here we want to know how only or square feet, okay, or the size of a house or the compound affect the price. But the multiple regression, they are considering of more than one independent variable. That's what we call it a multiple regression. They are considering more than one dependent variable and how that what will affect the price of what of a house. Okay. I hope I am clear.
Yes, I understand now. Thank you.
You're welcome. Okay. So I think I'm trying to um, I'm trying to get the attendance list, but hold on for me. Let me. So I want to know, is everyone on the Discord channel? If you are here on the Discord channel, if you are not on the Discord channel, let me know. So we are all on the Discord. Okay, Ibrahim. So you're all on the Discord channel, right? Okay. All right. So then I'm going to share the attendance to the Discord channel, and then I'm going to share the attendance on the Discord channel. Okay. Right now finding a difficult. Okay. So if there is no question again, enough. Okay, now go ahead and ask the question. Yeah, I think enough responding. So if that is the case, that will be the end of our today's session. And hope you guys enjoy your time. And then Yes. Yes. If you can keep it running, keep it running, keep it coming. So you want to take everything gathered with it. And I also want to admonish us to try our hands on what we can, because when things keep on piling up, you might one or the other make something, right? So, because next week we're also going to have another section. We having section for the no free mind. So, for what you have done, if not for anything, if you have worked on classification, how to fix classification model, that is logistic regression, and how to fit linear and multiple regression. So, you can try your hands on this the next time you meet when you're going to work on supervised learning. All right, so yes, go ahead, ask your question. Or you just ask a question.
Yeah, please, on the Discord channel, I've not seen your post. I'm thinking maybe there is a machine learning channel that I've not joined. I don't know.
Okay, then yes, there is a machine learning channel, and if you have not seen it, it's practically because you have not chosen your career path, right? So I think all you have to do is hold on for me. Let me guide you on how to choose your career path. Okay.
Thank you. Thank you.
Can anyone help me? I think I'm kind of like find difficult. Can anyone help me to locate the portion on the Discord where you choose a channel you belong to, and then will be added to the machine learning channel? Can anyone help? Okay, so Elizabeth, this is I'm leaving my email address there. Reach out to me and then I'll help you out. Okay.
Okay. Your email.
So
Are you pasting it on the chat?
yes, I'm leaving it on the chat.
Okay, thank you. Okay.
All right, so yes, I'm going to share all that is done today on our Discord channel. Then you can go over there and then you can also access on your own. And I'm admonishing all of us that during your practice, if you find something confusing and need more clarification, you can reach out to me. Right? You can just reach out to me and then I'll help you out. I'm here to help all of you out. And this part of the learning, uh, you have to also encourage yourself by practicing a lot. Keep your hands dirty, always keep your hands dirty, and personally, you'll get most of what we are doing. Right? So this is all for today. See you all next week. But in the course of the week, we're going to hear from me a lot. And we keep on interacting on the Discord channel. So have a lovely weekend, everyone. And okay, Elizabeth.
Yeah, please, could you tell me your username on Discord? Maybe I could send you a direct message, please.
All right. So this is my username.
Thank you very much, sir.
You are welcome.
Thank you. Great day.
Okay, so thank you, everyone. See you next week.
Sorry, didn't drop the attendance link.
I'll drop it in the Discord channel. Okay. Think we are kind of like having issues in retrieving it now.
Okay, sir. Thank you, sir.
You're welcome.
Hi, Dixon. Sorry, please what about the attendance link?
I'll drop it in the Discord channel.
Discord. All right.
Yes.
All right. Thank you.
You're welcome.
Everybody do filter. That's the hardest thing.